This is Kavin. This is my ICP-5. ICP-5 consists of two questions. The first one is to delete all the outlier data, and the second one is to create multiple regression for the wine quality. So now coming to the code, I've used the Jupyter Notebook to do the problem. So in the first question, before going to the question, let's see what an outlier is. So the outlier is something which is deviated from the normal form is called as outlier. For example, if this is the data, some data points which is deviated from the whole data set is called as an outlier. So first thing is we have to import the library where pandas library is used to make the CSV file into pandas data frame, which is easy to do operations on pandas data frame. Next one is to import the dataset. So we use the dataset provided. So this dataset has several columns like sales price, sales condition, sale type, etc. So we have used the style ggplot to plot the graph on the size 28x15, and we have plot the graph. So here we could see the sales price, which is our target column, and the garage field. So the garage fields varies from 0 to more than 1400, and the sales price vary from 0 to more than 700,000 700,000. So if you look at the if you describe about the garage area, we could see there are about 1460 data points, which has a total mean of 472 and standard deviation of 213. So we could say that the 472 72 to 213 approximately is where the most of the data points are concentrated. So 472 plus 230 is about 800. So the garage area which is greater than 800 is going to be our outlier, and 472 minus 13 is about 260, which is again is going to be our outlier. So our target is going to be the data points which is less than 800 and greater than 260. Now if you describe the sales price, again we could see 1460, which is about 180921, and standard deviation is about 79,442. So if we take the sum, we could say it's about vary from all the ranges. So coming to the outliers, so and we cannot tolerate the null values, that is we cannot tolerate when garage field is equal to 0 or sales price is equal to 0. Here there's no null values for sales price, so we could remove this. Now if we run, so if we run this, the outliers are all removed, and if we plot again, we could see the outliers are removed. So all the data points are less than 800 and greater than 260. Now so we have used standard deviation because standard deviation is the measure that is used to quantify the amount of variation. For example, if we say in this data point, we could say the one standard deviation where the most of the data points are present. Now coming to the question 2. Question 2 is about creating the multiple regression for the wine quality. So again, running the Jupyter code for the question 2. First we have import the libraries path like pandas, numpy and matplot, where panda is for the data frame, numpy is for mathematical calculations, and matplot to plot the graph. Now if you see the if we see the first 10 data points of the data set, we could say the columns like fixed acidity, volatile acidity, citric acidity, etc. So we also need to include the numeric features, and if we find the correlation between the data columns, we could see the first one is quality. Quality is 1 because we are finding the correlation between quality and quality itself. So it's correlated, it's 100% correlated, and alcohol is about 47%, and sulfates is about 25%, citric acid 22%, and so on. And other data columns like pH chlorides are negatively correlated, and if you see the null values, count the null values on the data columns, it's almost all zeros, and we'll handle the missing values and build a linear model. So to build a linear model, we have removed the quality because quality is going to be our target, and split the data by 33%, that is out of 100 data points. The 66 data point is going to be our train data. 67 data points are going to be our train data, and 33 is going to be our test data. And fit a linear regression. So we have made the linear regression from the sklearn. So what is linear regression? So this is the linear regression. If the data point is in it's linear, then we fit the linear regression. The red line is the linear regression. So if you give some value in x, let's say if you give 30, it will find what value of y in the line. So if and calculate the performance, in performance we have seen that we have got 34% R square value and 0.01 RMSE, the root mean square error. So next, if we plot the graph between the predicted quality and the actual quality, we could get a graph like this. Says the graph between the regression, how accurate is our regression model is. And that's the end of the ICP-5. Thank you.